Hello everyone, myself Jambagi welcome you all for lecture number 3 on motion. In the previous clip, we studied the types of classical mechanics. The first one will be statics, that deals with the bodies at rest and their relations with force. And we have another type, dynamics, which deals with the bodies in motion and their relations with force. We also came across the part named dynamics and its types. The dynamics has two types, kinetics and kinematics. Kinetics describes the motion with cause, kinematics describes the motion without cause. We also got the idea about the terms such as object or a body, particles, physical quantity, frames of reference, like that. Dear students, we also studied rest and motion and how they are related to one another. We end the lecture by saying motions are complex. Now we are understanding the complexity of motion by taking its types. Types of motion. There are so many types of motion present, out of which I listed few here. First one will be random motion. Second one, translational motion. Third one, rotational motion. And fourth one will be oscillatory or vibratory motion. Let us try to understand those motions one by one. The first one will be random motion. The type of motion in which it is the type of motion in which objects or particles move randomly. The objects or particles move randomly. That is, they do not move along a definite path. That is known to be as random motion. The type of motion in which objects or particles move randomly. Randomly means wherever they want, that is taken as random. That is particularly, it is saying that they do not move along a definite path. The path isn't fixed here in this case. Such motion of a body or a particle is known as random motion. Take some examples here for random motion. The motion of dust particles. The motion of dust particles in wind or air. See, I figured out the two different pictures. So they are nothing but dust particles. One in the picture number 1, it is showing the dust particle boom out. So that motion is taken as a random motion. The particles in the wind or the dust, wherever they want, they are moving. So such motion of the particle is known as a random motion of it. Okay. So similarly, we have another picture, that is second picture. It is also a randomly arranged motion, that is a random motion. The particles here also moving randomly. So this is the first example, motion of the dust particles in wind or in air. Now second one, motion of the football while playing. While playing is on, the motion of the football. I'm taking motion of the football, not the person, okay? Not the passing even in the game. So the motion of the football, in these two pictures you will come to know. So the people are gathering towards the ball. Therefore, the motion of the ball is random. Here also in the second picture, the ball is moving from one person to another, again one to another. Similar to that, that is also a random motion. the football while playing, that is nothing but random motion. Similarly, we are having flying insect or bug. So considering the motion of the bug or insect or any other type of insect, their motion considered to be particularly for each bug that random motion. So this is the first picture and this is the second picture. By getting these pictures, I hope you are getting the examples right in. Similarly, we have one more example, that is movement of fishes inside the water. Movement of fishes inside the water. Look, there are so many fishes in the sea or seabed, you may call. The motion of the fishes are in random motion. This is the first picture. Similarly, second, and this is the third one. Dear students, don't worry about the motion as a whole, motion of these fishes as a whole, because as a whole they are maintaining a correct path. Or say one more example, that is flying birds. So each one of the bird, if you are considering, their motion is random. This is the first picture. Similarly, this is the second picture. These are the examples for random motion. Random motion of the object means it is moving randomly. Randomly means they are not moving in a specified path. They are not moving in particular path. That is nothing but random motion of the object or a body, or even you may call particle. Let us move to the next type of motion, that is translational motion. The type of motion in which every object or a particle has same displacement. The type of motion in which every object or every particle has same displacement. If the object maintains the same kind of displacement during motion, such type of motion of an object is known as translational motion. It is known as translational motion. In other words, you can define it as the motion in which all points of a moving body move uniformly in the same line or same direction. The translational motion is the motion in which all points of the body which is in motion move uniformly in the same line or in the same direction. Such type of motion is known to be as translational motion. The translational motion can be along a straight line. It can be, this type of motion can be in a straight line or along the curved path. It may be straight line, it may be having the curved path. The motion of an object which is in straight line is called as a rectilinear motion, and the motion of an object in a curved path, is known as a curvilinear motion. There are two types of translational motion. One is a rectilinear motion and other one is curvilinear motion, depending on its path. If it is maintaining straight path or straight line, then such motion of the body or an object is known as rectilinear motion. If the object maintains curved path or the object moving in curved path, that motion is known as curvilinear motion. So translational motion are having two kinds of it. Okay. Let us take the examples for translational motion. A train moving in its track is a translational one. This is the figure number 1. This is figure number 2. So picture number 1 suggesting that it is moving on a track, that is also because it has its same displacement, or it is moving uniformly in that path. That is nothing but translational motion. It is in the first case, and in the second, that is having a curved path, it is maintaining again the same displacement, and during its motion all points move uniformly. Okay, this is one example for translational motion, a train moving in its track. Let us take the second example, athletes running on a track. That is also a translatory one because they have same kind of displacement in their motion. So that is the picture number 1. That is also translatory one. Second is also a translatory one. Athletes running on the track. Running on the track is very much important. Whoever coming first or second, it doesn't matter here. Okay. So they are moving on a track. That is important. That is nothing but translational motion. Next one will be a stone falling straight towards the earth's surface or surface of the earth. In this picture, some of the stones are falling towards the earth. Say it is falling down straight. That is also a translatory one. An asteroid entering into the earth's atmosphere is also a translatory one. So this is another picture of a meteoroid falling towards the earth. So this is also one of the example for translatory motion. Similarly, coins moving over a carom board is also a translatory one. So getting into the picture, you come to know. I hope you understood all these examples easily after getting these pictures right. Let us understand another type of motion, that is rotational motion. The type of motion in which an object or a particle revolves in a circle. A particle or an object revolves in a circle about the same axis. About the same axis is known as rotational motion. Rotational motion is the motion in which an object or a particle revolves in a circle about the same axis is known as rotational motion. Examples: rotation of the earth on its axis is the simple example for rotational motion. Rotation of the earth on its axis. Earth is rotating on its own axis. So that is nothing but rotational motion. The rotational motion of the earth, as we already know, that causes day and night. We already aware that. Second example will be pulleys used to draw water from the well. Using pulleys, drawing the water from the well is another example of rotational motion. Pulley is going to rotate, by that you can get the water from the well. We have three different kinds of pulleys shown here in this picture. Pulley is rotating all the time, so the motion of the pulley is nothing but the rotational motion. Another interesting example of rotational motion is merry-go-round. You have already experienced this in merry-go-round, in fairs, in any entertaining parks. You will find merry-go-round. You already played, I presume. So this is also one of the example for rotational motion. And you are also experienced sitting in a giant wheel or a great wheel we call it as. So the motion of the giant wheel is also a rotational motion. The example for rotational motion. Motion of the giant wheel itself, again it is rotating on its own axis like this. It is moving its about its axis. It is rotating like this or maybe like this. So that is the example for rotational motion. And the most common example will be the motion of the fan itself. That is also rotatory or rotational motion. The motion of the fan is simply rotational motion. So whatever the type of fan, it is irrelevant here. The motion is always rotational one. Let us take one more type of motion, oscillatory or vibratory motion. A to and fro or back and forth motion of a body about fixed point is known as oscillatory motion. A to and fro or back and forth motion of a body about a fixed point. So nothing but oscillatory motion. If such motion is very fast, then it is taken as a vibratory motion. For oscillatory motion, you can quote the simple example of a pendulum. A simple pendulum is the best example of an oscillatory motion of the pendulum. I hope. So what do you mean by to and fro or back and forth? If you are asking, this pendulum bob is moving from this point and yet again it is coming to this point and again moving like this. This is called to and fro motion or back and forth motion of the body. So motion of the pendulum is the best example for oscillatory motion. Similarly, the motion of the swing or jiggle. So you are already experiencing it. I hope you enjoyed all these things knowing, but without knowing the physics of it, isn't it? Anyway, this is the another example for oscillatory motion. Again, the motion of the waves or wave motion is always oscillatory one. See, the motion of the wave is an oscillatory motion. Here in the picture number 1, the people are having the rope. One person is taking, it is fixed to the one end, and another person is also having that. Just if you give the jerk, the wave is going to form. That wave is nothing but, the motion of that wave is nothing but oscillatory. Such motion of the rope here is the example for wave motion. Okay, so waves are always moving like that only. That is always oscillatory one. Let us move to the examples for vibratory kind of motion. Vibrating spring, vibrating tuning fork are the best examples for vibratory motion. As I said earlier that vibrations are nothing but they are the fast oscillations. Fast oscillations are generally termed as vibrations. Vibrations of the spring gives the vibratory motion. Similarly, the vibrating tuning fork is the example. The motion of those the prongs of tuning fork gives to the vibratory motion. Similarly, vibrating string of a guitar, the motion of the string of a guitar is the best example for vibratory kind of motion. So the back and forth motion or to and fro motion of a body or an object or a particle is known to be as vibratory motion. I hope you understood all the points discussed today. If you are having any doubt, you may raise the question using my WhatsApp number. This ends today's class. With more videos, I'll meet you in the next week. Till then, take care of yourselves along with your family and friends. Bye-bye.